Next up in our program, I'm excited to welcome Martin Casado, who is a general partner at Andreessen Horowitz and invests in AI and infrastructure. Martin will share a presentation on the economic case for AI, followed by a panel discussion with two founders in the data space. Please join me in welcoming Mr. Casado.
Thank you. A16Z の Martin Casado と申します。どうぞよろしくお願いします。
I'm Martin Casado from A16Z. Thank you for this opportunity.
The entirety of my Japanese. So I appreciate you being here. What I'm going to be doing is giving an economic perspective of why this wave of AI is different. So the broad narrative on AI has been that we've had these winters and summers. Sometimes it's been good, sometimes it's not. But the reality is, if you look over the last 50, 60, 70 years, it's been constant progress. Not only has it been constant progress, but we've actually solved very critical problems along the way. In the 60s, we used expert systems for diagnosis. We're very good at beating Russians at chess. We're very good at identifying objects and images. We're actually quite good at robotics. Not only have we gotten good at these and solved problems, but AI has recently become quite a bit better than humans at a lot of things. For example, AI is better than humans at reading handwriting, and it has been so for almost 2 decades. And on top of all of this, we've learned how to monetize AI for large companies. Ad targeting, search, personalization, all of this is fueled by AI and has contributed a lot to the economy and a lot of business value. So AI is great. It's this magic thing. We've had it for a very long time. So the question I ask to you, all of you in the audience, is why have we then not seen a platform shift? Why haven't we seen new AI native companies in the last 20 years that are just because of the power of AI? We saw this with mobile, we saw this with the internet, we saw this with cloud, but we've never seen it with AI. That's the focus of this talk. And what I would argue is that even though the capabilities of AI are incredible, the economics are not necessarily, until now. So let me unpack that very quickly. There are many reasons why, historically, the standalone economics for AI have not been great. First off, they've tended to be applied in niche markets. So for example, playing chess is very impressive, but it's not a large business. The second point may be the most important, which is many of the applications that we use AI for require correctness. Take, for example, robotics. If you're incorrect, you could hurt somebody, and that has huge consequences. And getting exact correctness is very hard and very costly. I'll talk about that more. Finally, a lot of the applications historically have required hardware. Robotics is a great example. Clearly, this is very hard for startups to do, notoriously hard. And the final point I want to make, which I'm going to dig in throughout the rest of the talk, is the competition for AI is not other computers. The competition for AI historically has been humans, and humans are very, very efficient at a number of things. Let me give you a very specific example of robotaxi. So robotaxi is fully autonomous vehicles, right? Imagine Uber except for, fully autonomous. As an industry, we've invested $75 billion into robotaxi. Today, it is still more expensive to run a robotaxi than it is to use Uber or Lyft. And therefore, this clearly remains in the domain of large companies, right? No startup can invest $75 billion to create a product that's more expensive. I want to go in just a little bit more detail of how tough the problem is. So just to give you an example, if you take a modern robotaxi today, just the CPU, GPU unit, just that alone, right now, if you're doing 30 frames per second, probably consumes over a kilowatt of energy, and just running just that alone probably costs $3 an hour. This is after $75 billion invested, whereas a human brain runs on about 15 watts, so 1/100th, and in San Francisco is $15 an hour, so a little bit more expensive, but not a lot. So even in the case where you're just looking just at the processing unit, let's assume you do all of the work, get there, it's still the economics aren't that compelling. So my point is if we have a takeaway for the last 50, 60 years in AI, the takeaway is not that we can't build robot taxis. We can. It's not that we can't solve problems. We can. The takeaway is that monetizing that as a startup has just been incredibly difficult because the economics have not worked. Okay. So why am I up here? Why are we all excited? What is the opportunity? It turns out from an economic lens, this wave is much, much different. And as I will talk at the end, it's actually a great opportunity for Japan. It plays for something that Japan is very, very good at. So let me describe what I'm talking about when it comes to this current wave. So by current wave, I'm talking about generative AI. Sometimes we use the term large models. The way to think about it is you have a model, an AI model. It could be a language model. It could be an image model. It could be a voice model. And in comes natural language, like Japanese or English, and out comes some content. It could be an image. It could be a video. It could be a conversation. So that's what I'm talking about. So this has already been pushed into a number of very interesting applications that computers have not been able to do historically. Things like creativity, creating images. Things like companionship, an emotional connection. There are many very successful companies today that will be a virtual friend, a virtual girlfriend, a waifu. This is a very common thing today. And then the third one we call Copilot. So Copilot is a term that's emerging that means this is a helper, an AI helper, to get a task done. It could be helping you code. It could be helping you schedule something. So these are the categories that have already emerged, and it's only been a few years. Now remember I showed you previously a slide, and that slide said, here is why AI economics don't work. So what I'm going to do is I'm going to show the same slide, but show how it does not apply to this current wave. So instead of niche markets, this is clearly a very large market. Just video games and movies alone are almost a $500 billion market. The second, and very importantly, is correctness just isn't an issue in these domains. There is no notion of correctness if you're having a conversation. There is no notion of correctness if you're creating a fiction story or if you're creating an image. And if you get it incorrect, it's not that big of a deal, right? It's not like you're creating a robot. The early use cases are primarily software, so you don't have to solve that problem. And the last point is, it turns out that when it comes to language processing and it comes to creativity, the computers are actually very competitive relative to the human brain. So traditional AI is like robotics, and it's competing with a very old part of the brain, the part that has been picking strawberries or running away from lions, right? That part of the brain is probably 100 million years old. So it's very, very efficient. That's why the robotaxi GPU is 100 times more, requires 100 times more electricity than the human. But when it comes to creativity, language processing, that part of the brain is only about 50,000 years old. And the computers, economically, are actually much cheaper to use, just like they are for calculating numbers. So let me give you some specific examples. Let's say I use the program Ideogram to create the image of Martine as a Pixar character. So the cost to do that is about 1/100th of a penny, and it takes about 1 second. which we did. On the other hand, if you hire a graphic artist, what, $100 in an hour? It's probably more expensive than that. So this is 4 orders of magnitude difference. This is 100,000 times difference in economics. I'll give you another example on languages. So this is from a company called Instabase. Let's assume I have a legal document in a PDF. And I take that and I give it to an LLM, and then I ask it legal questions. So again, the inference is a fraction of a penny. It's very quick, whereas if I go to my lawyer, it's going to be hundreds of dollars. At this point, you're probably saying, aha, but the LLMs are going to be incorrect and the lawyer will be correct, which is clearly not the case. Having worked with many lawyers, they're wrong all the time, honestly. And LLMs tend to actually be more correct. A very nice aspect of these new models is that you're iterating with the user so that we can find correctness. So for example, if a lawyer gives you an answer, often we double check it, which you would also do with an LLM. These are just 2-point examples. It already shows an economic difference of 100,000, but if you think in the limit, the differences can be extreme. Take, for example, the creation of a AAA video game, right? These cost hundreds of millions of dollars, and they cost years to create, right? But every aspect of them, we have a capability to generate the 3D models, the characters, the story, the voices, the textures. And if you look at the total inference cost to create all of those, it should be a few dollars, right? So now we have internet scale economics, the difference between $100 million and, say, $10. So there's little wonder why we're seeing the growth of some of the fastest growing companies we've seen in the history of the industry and the fastest growing projects in the history of the industry. So this isn't theoretical. I mean, today we have solvent, fast growing companies that are taking advantage of this economic asymmetry, this economic shift. So let me try and put it in historical perspective, because I think this is very important. Historically, when marginal costs have dropped so much, 4 orders of magnitude, it changes the industry. So as we all know, microchips, that brought the marginal cost of compute to 0. Before computers, you had people in rooms calculating logarithms by hand for ballistics trajectories. That's where the term computer comes from, humans that are computing. When we created a computer, it was 4 orders of magnitude faster, and that brought on the compute revolution. This is IBM, HP, Cisco, Microsoft. The internet brought the marginal cost of distribution to 0. So prior to the internet, for me to get software, I'm old enough to remember, I would go to a store and I would get a box. And the time it took from them finishing the software to get to the store was probably 2 weeks, right? And if you look at instead the internet where it was just seconds, and the price per bit, and you'll have to just you'll just have to indulge me on this one. The price per bit was also about 4 orders of magnitude cheaper when the creation of the internet happened. So what we believe is, with the generative AI movement, these large models bring the marginal cost of creation to 0. So you've got compute, you've got communication, and you've got creation. And we think that that is enough. There's enough economic shift to generate an entirely new wave of economic companies. So let me talk very quickly about Japan before I end. So I've been coming to Japan for about 10 years. I helped open up the Japanese office for my startup here. I've done a lot of business in Japan. And I've got to really understand and respect the technology sector. Japan is incredibly strong when it comes to technologists, and it's always been a leader in AI, no question. But it has not, typically in software, been a global presence. And I think this is an enormous opportunity to change that. So anybody here from the government or an investor or a potential founder, this is very important to realize that the use cases now, the use cases that are working are ones that Japan has been historically very good at. It's movies, it's creativity, it's video games. And so I do think that, if you ever wanted to participate in private markets, now is the time to do it, particularly in this country. I'm going to make one final point before I end, which is that often when you see things like the cost drops a lot, we worry that it'll displace jobs. It's a very common concern. Now, this is an economic talk, so I'm going to give the economic answer, which is if you look historically, if the demand is elastic, if price drops, the demand more than makes up for it. This is called Jevons paradox. It happened during the microchip, it happened during the internet, and that actually means more productivity, more jobs, more value creation. That fueled an entire set of industries in the United States, and we believe that's going to happen again. So thank you so much for your time. I really appreciate that, and I look forward to having a conversation next. Thank you so much. よろしくお願いします。